So these are your major components of the combiner system. As you can see, we have 3 channels. We have the input that comes into the actual isolators from the radios, this point here, through the isolator, and we talked briefly about what isolators do yesterday. From there to the tuning cavity, to the junction, and then out to the antenna. So you have the S is your secondary load that's facing toward the radio. P is your primary load facing toward the antenna. Most combining systems have a single cavity. There are certain situations we'll have dual cavities. The process to tune it is basically the same, whether it's a single or dual cavity per channel, but it just it's just a couple extra steps. You do the same stuff, you tune the cavities, do a coarse tune individually, and then you do the fine tune in system. For public safety applications and anything that's trunked where you have a high duty cycle, we are recommending to run the little bit larger loads. These loads are actually 60-watt loads. So this is the load that we recommend today. And that's again because a lot more of the users are using the radios with a higher duty cycle than they used to. You have control channels that run 100% of the time, and you have these trunk systems or public safety. If there's a major incident, the public safety guys are all talking. They're talking back to back to back to back. Over time, these systems will start to heat up, and the heat generally happens in the isolator. And when that happens, the panel will pull some of that heat away, but these loads also provide a heat sink. And so it pulls that extra energy out of those isolators so they don't get hot. And if you have to add a channel to a combiner or move equipment around, if you're looking at this orientation here, the energy is coming in, so you're looking down the isolator. If the loads are on the right-hand side, then it's a forward orientation. If this were reversed and the energy was coming in this way and the loads would be on the left side, as you see here, then that would be considered a reverse orientation. So if you order a new channel, if you're going to expand a combiner and you're ordering the equipment from us, we need to know whether it's a forward or reverse isolator. So an example here, energy's coming in, goes down. The loads are on the right-hand side when you're looking down the isolator. So this is a forward. This one here on this side, energy comes in, you're going down. The loads are on the left-hand side. That's reverse orientation. So depending on where on that panel the isolator is going to go, that's when we need to know whether it's going to be forward or reverse orientation.
I got because of the position in
Yes.
the panel, you can select if this will be an input or this is will output or the opposite.
Correct.
That's why when they will add another cavity here, they need to know the position of the isolator
Right.
in order to see how would be the input and how would be the output,
Correct.
which is called the reverse
And forward. So on this guy here, this top one is a forward because we're coming in on the left side.
okay.
But this guy here, we're coming on the right side. This is a reverse, this
Okay.
particular isolator here.